The use of XY charts today is to discover a more general pattern. Now, do not use XY charts as the only way to graph a function. Once the pattern and behavior is learned, you no longer need to rely on the XY chart. This is really important. Sometimes people think, oh, I'll just ignore everything that's going on here. We're trying to talk about mathematical thinking, and some people say, "Oh, I just don't need the charts. I'll just rely on the charts. I don't need to think about what's really going on," and that will cause problems. I can promise that. So you really should go through these computations that you're seeing here on your own instead of just watching. The computations themselves, I promise, aren't bad. We're just talking about things like 2 squared plus 3, stuff like that. So I would suggest really going through the computations on your own because doing so will make the conclusions more convincing to you. So how are the graphs of y equals x squared and y equals x squared plus 3 related? Well, to just explore for a moment, let's write out a chart of x and y values. Again, this is just for exploration. So when you plug in -2 for x, -2 squared is +4 for y. -1 for x translates to 1 for y. 0 for x becomes 0 for y. 1 for x means you'll get 1 for y. Plug in 2 for x, 2 squared is 4. That's what you get for y. And then let's take a look at y equals x squared plus 3. So plug in -2 for x, and then you have 2 squared, which is 4, still plus a 3. So 4 plus 3 will give you 7. We're just following the order of operations here. Plug in -1 for x, and you'll get 4 for y. Plug in 0 for x, and you get 3 for y. If you plug in 1 for x, you get 4 for y. And if you plug in 2 for x, you'll get 7 for y. Now, if you were to plot these points carefully, for y equals x squared, you'd end up with this parabola shown here. Then take a look at this graph. Plugging in, when we plugged in -2 for x, you get 7 for y. That means that at that same x value of -2, instead of the y coordinate being 4, it's 7, which is bigger. So that's the graph is higher up. And so you've seen this. That what you're seeing here, what you'll really notice if you graph this carefully, is a shift. So to answer the question after the exploration, you take the picture of y equals x squared shown here, and just take the part in blue, just the graph, and you shift it up 3 units to get y equals x squared plus 3. The key thing is to note that if you know the graph of this thing, then the plus 3 here is going to shift the picture up because the y coordinate has grown by 3 units. Let's take a look at a picture. So here you see y equals x squared plus c. Currently c is set equal to 0. But we can take the slider and see what happens when c is equal to, say, 5. Or see what happens when c is equal to -4.5 or -8.7. So, based on using the XY charts, again, that is not the only method to graph. We are trying to use the charts to discover this pattern and behavior that we're just about to talk about. Question: if c is positive, what do you do to the graph of y equals f of x? To get the graph of y equals f of x plus c, you have to shift up by c, or shift up by c units, or up c units, or something like that. What about if c is positive, what do you do to the graph of y equals f of x to get the graph of y equals f of x minus c? So something like y equals f of x minus 5. Well, you shift down by c units.